Alright, so in the last video we looked at the idea of annual effective rate, and we found out that 3% compounded semi-annually is not twice as good as 3% compounded annually. We don't just add on 3% after 6 months and then add on 3% after 12. What we do is we just take whatever the rate is and we divide it by how many times we're making the payments. So semi-annually, you divide it by 2. So after 6 months, if you had an investment compounded semi-annually, you would get your first interest payment of 1.5% after 6 months, and then at the end of the 12 months, you're going to get that whole total times 1.5% again, or you're going to get 1.5% interest on that whole total. So it's a little bit better than 3%, but not much. Now this video we're going to show you that eventually it's just going to stop getting better. It's going to kind of reach a plateau. I forgot the Y there. Alright, so we're going to start off with 3% compounded annually. All we have to do is fill in our formula here. So we're going to have our annual effective rate. Sometimes we have the subscript A, IA. This is going to equal, well, we'll have 1 plus 0.03 over 1, because we're only, M is our number of compounds per year, so we're just dividing by 1, all raised to the power of 1 times 1, right? And we set n to equal 1 for this annual effective rate, and it just makes our lives a lot easier. Alright, then we have minus 1 to finish off this formula up here. And if you just go ahead and do this in your calculator, you're going to find out that, big surprise, we're going to get this is equal to IA is going to equal 0.03. Alright, which equals 3%. So big surprise there. 3% compounded annually is equivalent to 3% compounded annually. Alright. I hope I haven't lost anyone there. No surprises here. So we're going to move on to the next one. 3% compounded semi-annually. So again, we can solve this. We'll have IA is equal to, again, the A is up to you. I don't always write the A. 1 plus 0.03 over 2. Right now we're compounding twice per year. M is equal to 2. And then we'll have M is 2 times 1. We don't really need to write this 1 every time, but it's just habit. It exists there, so we'll just get in the habit of writing it. And if you go ahead and do this in your calculator, you're going to find out that your annual effective rate is actually going to equal 0.030225. Alright, and that's also, that's equal to 3.0225%, right? 0.225%. Okay, so this is saying that if we compound 3% semi-annually, so we take whatever investment we have, times it by, add on a 1.5% interest after 6 months, and then again compound, add on 1.5% interest of the new total after the whole year. That's the same as just compounding once per year at 3.0225%. Now, just before we move on, I'm going to show you that this works, so you don't get confused, because this can be kind of a weird topic. So first of all, we'll just do we'll just find out what the future value of an investment at this percentage is here. So we're going to go up here. Maybe we'll switch colors. So if we have future value is equal to present value of 1 plus I to the n, right? So let's say that we are going to invest like $100 at this 3.0225%, so that would be 1.0302225. And raise that to the power. We're just going to invest this for 1 year. Well, you're going to see that this is going to give us $103 and well, 0.225. So $103.02. All right, now we're just going to show that this is the same if we use 3% compounded semi-annually. So remember the way this is going to get kind of messy, but bear with me. This is probably a good demonstration just to make, anyways. So remember we say we take that 3% and we're going to divide it by 2, right? So we'll have 0.03 over 2. That's going to give us this semi-annual compounding interest rate of 0.015 or 1.5%. And we're just going to apply this twice to whatever our initial value was. So say we're taking this $100 investment, okay? So we'll take 100 and we're just going to multiply it by 1.015. And that's going to give us a value of, well, $101.50. Now what we do is we take that value, we take 101.5, and we multiply that by, again, we want to use that 1.5%, so we multiply it by 1.015. That basically just adds on 1.5%, and when we solve that, you're going to find that this is going to be equal to Well, it'll be exactly the same. So we'll have 103, it's 163, that's $103 and, well, 2 cents, but like that. It'll work out to be exactly the same. So you're noticing, yeah, we're not compounding, we're not adding on 3% both times. So it's very important that you see this, and that's just kind of like the red one here is just the really rough way to visualize it, and the more official way is to do the green and then the purple. But anyways, that's just for demonstration. Sometimes that can be really confusing. Okay, we're going to stop talking now. We're going to keep moving on. So we want to do 3% compounded quarterly. So what we do is we just have IA is going to equal 1 plus 0.03 over 4, because quarterly means we're doing it 4 times per year. Okay, so we'll have to the power of 4 times 1 minus 1, and we're going to get our annual effective rate when we compound 3% quarterly to be 0.030, that's a 339. This, you can obviously see that this just translates to 3.0339%. And for the same reason, we could do the same example here and find out, one compounding period, or like compounding this once at 3.0339% is the same as compounding it 4 times at whatever this number is divided by 4. I have no idea what that is, but you can easily find out by solving the same purple and red type of logic. Okay, moving on. We're going to do this 3% compounded daily. So we're going to compound this 365 times in a year. So we'll get 1 plus 0.03 over 365 to the power of 365 times 1 minus 1. Now, if you solve this in your calculator, we're going to find that our annual effective rate is actually going to be 0.03453. Okay, this is the same thing as, I think I missed a 0 in there, 030, like that. So we're going to have 3.0453%. So if you're a banker or someone ever tells you that you can get an investment that's compounded daily, obviously it's better than compounded annually. We're up by 0.4%, but it's not the hugest deal in the world. Now, just for fun, we're going to do 3% compounded continuously. So all that you do for this is you're just going to pick a really big number. So let's have 1 plus 0.03, and let's say, I don't know, 20,000. That's a pretty big number. You can probably do 10,000 and get away with it, but whatever. You can pick a bigger number if you want. All right, so we're going to have this raised to the power of 20,000. Times 1, not really doing anything, minus 1. And we're going to find the annual effective rate when you compound continuously at 3% is going to be 0.03045. All right, and this translates obviously to, this is 3.0455%. So we've made a huge jump. We're up to 20,000 compounds per year, and you're barely making any substantial increase at all. So that's just a quick way to visualize taking the same amount of interest and compounding it once a year, twice a year, 4 times a year, or etc., and seeing the type of difference. And obviously we're going to level off even right around here. Once you get past about 4, it doesn't really matter anymore. So anyways, and if you were to do this for 20,000 times in a row, that would take forever. So this is definitely a faster way to find the annual effective rate.